Hey guys, this is Rishendra. Last week we talked. Last time I completed about Lang chain. So today we'll start retrieval augmented generation. So yes, I know that you heard retrieval augmented generation like a little bit in when I told you about prompt engineering and Lang chain. So this is like the full explanations about the retrieval augmented generation. So retrieval augmented generation um, is an AI architecture that combines information retrieval with large language models. So instead of relying on only on what the model le- learned during training. Retrieval augmented generation first searches an external knowledge source and retrieves the most relevant information and then uses that information to generate a more accurate and up-to-date response. So, in simple words, retrieval augmented generation allows a large language model to look up information before answering a question. So, without retrieval augmented generation, if you give a question, it will just simply give you an answer without looking up any information. But uh, with retrieval augmented generation. So if the user gives a question and the question goes to the retriever and then it retrieves the relevant documents about the question and then it goes to the large language models, goes through the large language models, and then it will give you an accurate answer. So this makes the model more reliable because it can access the external knowledge instead of depending only on its internal memory. So why retrieval augmented generation was introduced? So large language models have several limitations. And so the first limitation is limited knowledge. So the model only knows information that existed before its training cutoff. Example, a model trained in 2024 doesn't know the events from 2025 unless connected to external data. Second limitation is hallucination. LLMs sometimes confidently generate incorrect information. Example, if the user gives a question like who won a fictional award, so the model might invent a winner. So retrieval augmented generation reduces hallucination because it retrieves the actual information instead of just giving you random information. Next limitation is private company data. So a normal large language model in doesn't know internal company documents. For example, employee handbook, HR policies, medical records, research papers, and company database. So, retrieval augmented generation lets the model search those documents before answering. And the last limitation is dynamic information. Some information changes frequently. Example like product prices, weather, stock prices, company policies, and medical guidelines. So retrieval augmented generation retrieves the newest version. So what are the core components of retrieval augmented generation? So a retrieval augmented generation system mainly consists of uh, user query embedding models, vector database, retriever, relevant documents, prompt construction, large language model, and then the final output. So let's understand each part. So the first one is user query. So everything begins with the user's question. Example like what is the leave policy for interns? So the system receives this query. Next is embedding model. So this is one of the most important concepts. So an embedding is a numerical representation of text. So instead of storing words as a plain text, they are converted into vectors. So for example, if you have a word like dog, so it is converted into vectors like a dog can be converted into 0.23 comma minus 0.81. It's like it will be converted into vectors. So why they have embeddings? Why embeddings? So computers they don't understand language and they understand numbers. So embeddings allow semantic comparison. So instead of just matching words, they match meanings. So, for example, if you have a query like the vacation policy, so and the document like it gives a document like employee leave rules. So the keyword search may fail, but embedding search succeeds because both have similar meanings. And so some of the popular embedding models are OpenAI, like and EFI embedding, Nomic embedding, and sentence transformers. Next, sentence transformers. Next core component is document collection. So before retrieval can happen, documents must exist. Examples like PDF, Word files, CSV, a database, or maybe a website. So these documents become the knowledge source. Next uh, is document loading. So the system first loads the document. Examples in lang chain like PDF loader, CSV loader, text loader, directory loader, or maybe web-based loader. So the purpose of document loading is it converts raw files into readable text. Next component is document cleaning. So documents are cleaned before indexing. So common processing methods are like HTML, extra spaces, empty lines. Uh, so common pre-processing removes HTML, extra spaces, empty lines, duplicate text, and special symbol. And they normalize lowercase, then maybe Unicode or encoding. Next component is chunking. So LLMs cannot process huge documents efficiently. Therefore, documents are divided into smaller chunks. So, for example, the original 500-page PDF can be divided into maybe like 10 chunks or maybe 20 chunks or 100 chunks. So why chunking? Because retrieving can an entire book wastes tokens. So instead, the retrieving so instead we can only retrieves the relevant section. So The typical sizes for a chunk size are like 256 tokens, 512 tokens, and 1024 tokens. Next is chunk overlap. So sometimes information spans multiple chunks. So for example, if in chunk one you wrote like machine learning is, and in chunk two it's like used in healthcare. So without overlapping, the information gets lost. So overlap preserves the context. Next component is embedding the chunks. So each chunk becomes a vector. Example, for the first chunk that it says that the employee receives 20 vacation days, and the chunk is embedded, like it is converted into numerical vectors. So every chunk gets stored as a vector. Next is vector database. So the embeddings are stored in a vector database. So unlike MySQL, vector databases store vectors. And the popular vector databases include FAISS, Chroma, Milvus, or VV8, or maybe QDRAT. Next component is vector search. So when a user asks a question, the question also becomes an embedding. So it's like once the user asks the questions, the question goes through embedding, and then it is compared with the stored vectors, and then it checks the most similar chunks. So most similar chunks. So that's it for today, and there are four more components left. So I will continue with that tomorrow. So yeah, that's it for today, and I'll see you again tomorrow. So yeah, bye.